So in this video, we'll be learning how to integrate exponential functions with U substitution. Let's start with the most basic example. So the first thing that you need to see is you need to check the exponent of x here. So of x here, in this example, is going to be 1. Now, if it's 2 or more, then you need to use U substitution, which I'll be explaining later. So let's start with the most basic example right now. So whenever it's 1 or it's just e to the power of x all over the derivative of the exponent, which in our case is x. So the derivative of x is just 1, so you just divide it by 1, and you can never forget to add c here, so the constant c of integration. Let's take another example now. E to the power of 2x dx. So in our case, again, we check the exponent of x, so it's 1, so we can use the same easy way again. So it's going to be e to the power of 2x all over the derivative of 2x, which is 2, plus c. Let's do one last example before moving on to U substitution. E to the power of negative 9x dx is equal to e to the power of negative 9x all over the derivative of negative 9x is negative 9 plus c. So this is quite easy. Now let's move on to U substitution. So in this example, we need to find the integral of x to the power of 3 and e to the power of x to the power of 4. So in our example here, we have x to the power of 4 over here. So we do need to use U substitution. So you always have to replace u to be the exponent of e here. So that's a rule. So it's going to be x4, and if we derive both the sides, it's going to be du is equal to 4x3 dx, and now we can rearrange and rewrite it as dx. So if we bring 4x3 to the other side, it's going to be dx is equal to du over 4x3, and now we can substitute dx with this dx. So we get the integral x3 e to the power of u now, and dx can be rewritten as this. So it's going to be du over 4x3, and x3 cancels out with x3. We can take 1 over 4 outside, so 1 over 4 integration of e to the power of u du, and as we know from before, the integration of eu is just eu, so 1 over 4 eu plus c, and simplified this more because we always need to remember to substitute what we did in the beginning with. So let's substitute u with the original value, 1 over 4 e to the power of x4 plus c. So in our next example, we need to decide what to take u as. So for me, it's more easier to look at the problem when we don't have a square root. So I'm just going to rewrite it as integration of e to the power of x, open brackets 1 minus e, x to the power of half. So here we can take this as u. So our u, actually let me rewrite this in a more better way. Yeah, as I was saying, so u is going to be 1 minus e to the power of x, and du is going to be then negative e to the power of x dx, and again we can replace this part as u, and oh yeah, I forgot to write dx here. So our final thing will be e to the power of x, and then open brackets u half to the power of half, and dx is going to be du over negative e to the power of x, and now this can cancel out with this, so we are left with negative. Don't forget about that. So it's going to be -1 integration of u to the power of half du, and to integrate this it's pretty simple. -1 outside, and it's going to be u 3 over 2 over 3 times 2. And simplified this more, I'm going to take the negative in now, so it's going to be and I'm just going to replace u also, so negative, and then 1 minus e to the power of x to the power of 3 over 2 over 3, and we can take 2 over here, so it's going to be -2, and this is the final answer. So the most important thing is what you take u as. Normally it's going to be the exponent of e, or if you see an example like this, you can see that it was pretty obvious that you have to take the inner part of the brackets. So in our next example, again we need to decide what to take u as, because if we take the denominator, we can replace dx with du, and it's going to go on the bottom right, the derivative. So we always take the denominator in such cases. So let's take u to be e to the power of x minus e to the power of -x, and if after we derive this, we're going to get e to the power of x plus e to the power of -x dx. And now you will understand why I took the denominator, because once we rearrange this and rewrite this, it's going to equal to dx is equal to du over e to the power of x plus e to the -x power of -x. And yeah, so once we rewrite this now, so it's going to be ex plus e to the -x, and this is u now, and times du over e to the power of x plus e to the -x. So now you can see that we can cancel this with this, and if we took the numerator here, it would have been, it resulted in this u over this part times du over this part over here. So we wouldn't have be able to cancel it out. So once we do that, we are left with integration of 1 over u du, and the integration of this is just ln u plus c, and now we can replace u with what we have from the original part, and it is equal to 1 e to the power of x minus e to the power of -x plus c. So in our next example, we have e to the power of 1 over x to the power of 2. So as mentioned before, you always take the exponent of e here. So there's going to be u is equal to 1 over x2 to the power of 2, and we can rewrite this as x to the power of -2, because we just bring it up. So I'm just going to remove this actually and write it as this, and now we derive both sides again, and we get du is equal to -2x -3 dx, and now we can substitute back into the original solution. So it is going to be equal to e to the power of u over x3, and dx is going to be replaced with du over -2 x3. And you can realize that we have negative x3 here, which can be rewritten as, if we take this up, it's going to be x3, so it's just going to be x3 then over 1. So we can just rewrite this. I can just take this up, x3 du, and this cancels out with this, and we can take -2 outside. So the final thing that we are left with is -half integration of eu to the power of e du, And the integration of this, as we know from before, is just EU plus C, and now we replace U with the original value, and we get negative half e to the power of x to the power of negative 2 plus C. So what do you think we should start this problem with? So we can notice that we have 3 numerators and a denominator. So the first thing that we could do is we can rewrite this as 3 separate fractions. So let's do that. So integration of e to the power of 3x divided by ex plus 4e to the power of x over ex plus 5 divided by e to the power of x dx. So now when we go to the basics, if we have something like x to the power of 6 divided by x to the power of 2, we just normally subtract the exponents, right? So 6 minus 2 is going to be x4, or let's say like x to the power of 3 divided by x is just x to the power of 2, right? So we can do the same here by simplifying this. So we get integration of 3x minus x is just e to the power of 2x. Here this can just cancel out with this, plus 4 plus this, we can bring e to the power of x up, so it becomes 5e to the power of negative 1 x, negative x. And now we can just integrate this normally. So this is going to be e to the power of 2x divided by the derivative of 2x, which is 2. This is just going to be 4x plus 5 e to the power of negative x over the derivative of negative x is negative 1 plus c. Now I wouldn't say this is a shortcut, but this is a method on the calculator where you can recheck your final answer by integrating on the calculator with random numbers. So I will be making a short video on how to do that in my next shorts. So basically what you have to do is once you find the final answer, right, you can type on your calculator, if you have the integral option, the equation, and you can put any two numbers. So let's say 1 and 2 for the integration, and you can find the final answer of the question, and in your final answer you substitute 2, so all the x's become 2, and then you do minus, and then you write the final answer again with substituting with 1. And if the answer is the same, this means that this answer that you get is correct. So I will be making a video on that soon, so I can show you guys how to do that. It'll be more simpler if you see it. And yeah, that's it. Thanks for watching.